Yes, yeah. Good evening all. So in the last class, I was briefing you about Apache Spark, why PySpark, need for PySpark. PySpark features real-life usage of PySpark. Spark is an open source distributed cluster computing framework with in-memory computation in parallel process style used for large-scale data processing. Right? Yes. It's a general engine for big data analysis and computation. It's a very high-speed processing execution model. It is a very high-speed processing execution model which process huge data in quick time. Spark is 100 times faster than normal disk processing. Why PySpark? It is a Python API to use Spark. The Python API to use Spark, right? Yes. Yes. So I say it's a Python. The PySpark is one of the lightning fast technology designed for fast computation. Running a distributed SQL, it is used for creating a data pipelines, ingesting data into database, running ML algorithms, working with the graphs or data streams. Working with graphs or data streams. Need for PySpark, right? Need for PySpark, we have got large amount of data getting generated. So this data contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful business information. So we need to extract some valuable information from the raw data. So we require a more efficient tool. Right? Yes. To perform these different types of operations on the big data, we require a more efficient tool to perform different types of operations on this big data. So there are various tools to perform this multiple tasks on this huge data, but these are not so much fast processing. So we need some scalable and flexible tools to crack this big data and gain some benefit from it. So PySpark is such a kind, right? Yes. So combining Spark and Python is very efficient for the world of big data. So that's why Apache Spark community came up with a tool called PySpark, that is Python API for Apache Spark. Python API for Apache Spark, right? Yes. Yes. And which one is preferred, like Python and Scala, right? Spark can be implemented in multiple languages. Which one is mostly preferred, right? Yes. Python is interpreted and dynamic type. Scala is statically typed. Python has a huge community. It supports around 89,300 modules. Scala community is smaller, used only for Spark. Python contains powerful libraries. It contains powerful libraries for data science, graph, and streaming. So Scala's libraries are less compared with Python. And here Python is slower compared with Scala. Scala is faster than Python. Okay. So main features of PySpark, in-memory computation. So storing and processing both happening within the memory level. Lazy evaluated, executing the data flow and demand by performing an action. Until then it's not going to get executed. Partitioning. Spark data is divided into partitions. Spark data is divided into partitions and are distributed across multiple RAMs of multiple worker nodes. If partitions, if you've got multiple partitions, then only parallel processing is going to persistence. Using already executed transformation output. No need to re-execute. Persistence means already executed transformation output, reusing already executed transformation output. No need to re-execute. No need to re-execute, right? Yes. Immutability. Spark data objects are immutable. Means they cannot be modified or changed. Fault tolerance. Spark has powerful fault tolerance model. Has got powerful fault tolerance model. Motivation towards Spark. Motivation towards Spark, right? Yes. So if you see the speed of Spark as compared with other things, right? So if you take the other databases, they've taken hours. We've taken Yahoo has taken a table of 100 TB consisting of 1024 columns. Task sorting based on 16 columns. Sorting based on 16 columns, right? Yes. So Oracle has taken around 3.5 days to process this. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netija has taken 3 hours, right? Yes. Hadoop has just taken 3.4 minutes, where these have taken days of time, where these have taken hours of time, but Hadoop has just taken minutes of time. But Spark is 100 times faster than Hadoop. Means see the speed of Spark as compared with the other things on this Hadoop also. Spark is for batch applications, for millions and trillions of record. It is not for online applications. Right. Spark can be coded with Python. Spark can be coded with Python. Spark can be coded with Scala or Java and or language. Default. Spark by default. Spark by default coded with Scala language. Spark data objects. Spark data objects, we call it as RTDs and data frames, right? Resilient distributed. Today I'll be discussing about it. And real life usage of Spark means in the commercial sector it is used. Apache Spark real-time processing. Most of this bank and financial fields they are using Spark to retrieve the customer social media profiles, and for credit risk assessment, fraud detections, for healthcare, analyzing the patients who is going to face that issue. Entertainment industry like Netflix using Apache Spark for its real-time processing. It's process 450 billion events per day. Trade and e-commerce. The leading e-commerce websites like Flipkart, Amazon, all this they're using Apache Spark for advertising. Right. The other websites like they're used for enhanced customer experience, and even in the tourism industry to provide advices to millions of travelers by comparing thousands of tourism sites. So I can say like Spark is a very high-speed processing execution model for processing huge data. Yes. Now coming back to this Spark. So Apache Spark. We talk about the evolution of Spark, right? Yes. Spark was developed by Metaxaheria. Metaxaheria in AMP lab. In AMP lab, Berkeley. In the year 2009, Spark was developed by Metaxaheria in AMP lab. In the year 2009. Spark was open sourced in the year 2010. Spark was donated to Apache Software Foundation. Apache Software Foundation. In the year 2013. So evolution of Spark, it was developed by Metaxaheria. It was open sourced in the year, it was by PySpark. Okay, these things. Spark was default written in Scala language. I said Scala is the native language of Spark. Now, if you see differences between Spark and other technologies, right? Yes. Tej and Spark, right? Yes. Both follows DAG model. Both follows DAG model. Directed acyclic. Both follows DAG model. Directed acyclic graph. Both follows DAG model. Directed acyclic graph model. The difference between the technologies like Tej and Spark both follows directed acyclic graph model. Tej doesn't follow in-memory computation. In-memory computation. So Tej doesn't follow in-memory computation, but Spark is in-memory computation system. So Spark has got a very high speed. Spark has got very high speed as compared to Tej. Spark has got very high speed as compared to Tej. Okay. Do you want any other in-memory computation systems, right? Yes, other in-memory systems, right, in the market. HANA. Both follows in-memory computation, both follows in-memory computation. But HANA is not distributed. Both follows in-memory computation, but HANA is not distributed, but Spark is distributed. Distributed means Spark has got a distributed RAM, right? But there is for HANA, there is no distributed RAM, right? It is mainly designed for, Spark is mainly designed for batch applications, right? First one is batch applications, millions and trillions of records, batch applications, not for online applications, not for client server, not for request response. For iterative algorithms. For batch applications, for iterative algorithms. For interactive queries. And for streaming. For batch applications, iterative algorithms, for interactive queries, for streaming. Hadoop MapReduce and Spark. Talk about Hadoop MapReduce and Spark. If I say in Hadoop MapReduce execution is going to happen, MapReduce drawbacks. Transformations cannot be reused. Transformations cannot be reused. Bad for iterative algorithms. Transformations cannot be reused means you already executed some transformation again in another task, right? If you want to reuse that transformation, we can reuse that output of the transformation. You cannot reuse it. You need to re-execute again from the beginning, right? Bad for iterative algorithms. Most of these ML algorithm, machine learning algorithms are iterative in nature. Iterative in nature, right? But MapReduce is bad for iterative algorithms. Not a flexible parallel process. Not a flexible parallel process. No, it's not a flexible parallel process. See, this MapReduce, Hadoop MapReduce is meant for parallel process, but first mapper phase executes, next reducer phase executes, one after the other, not a parallel, sequentially it executes. So that's why I'm saying it's not a flexible parallel process. So it's a slow processing as compared to slow processing. Spark is 100 times faster. Spark is 100 times faster than Hadoop MapReduce. Now, next. Spark and Apache Pig, we say, right? We used to have Apache Pig. Both are data flow languages. Both are data flow languages. But in Pig, see, Apache Pig is one of the best scripting language. See, if you see, it's one of the best scripting language, with very less coding, right? We can perform the task. But in Apache Pig, the entire data flow is converted into one MapReduce job. But the entire in Pig also the data flow execution happens. Entire data flow is converted into one MapReduce job. And again, MR is bad. MapReduce is bad, as we discussed, right? Yes. Spark and Flink. See, both are Apache products. Both purpose and objective are same. Both purpose and objective are same. In the initial versions of Spark, right? Spark was weaker. Spark was weaker in machine learning. The heart of analytics. The heart of analytics is machine learning. So Flink was dominating Spark. Spark. before Spark 1.6. See, before Spark 1.6 version. Before Spark 1.6 version. Spark was Flink was dominating Spark. So if you talk in 2016, 2016, 17, 2017, 18, 19, right? 2016, 17, 18 means most of the people when they started updating Spark, once they got updated, there was a talk, right, that Flink is dominating Spark and Spark will be away from the market and Flink will dominate it. Okay, it was real. Flink was dominating, but first Apache Spark, this Apache Software Foundation, they first introduced both. First introduced Spark, next they introduced Flink. But what happened? Okay, it was dominating, but from Spark 1.6 version onwards, but from Spark 1.6 version, but from Spark 1.6 version, Spark got a powerful features. Spark introduced powerful features which almost is equal to Flink. But after from Spark 2.2, from Spark from from Spark 2 version onwards, Spark 2 version onwards, Spark has got very powerful libraries for machine learning, for streaming, for this interactive queries, right? So totally it dominated Flink again. Spark has got powerful libraries, where it is totally dominated Flink. You want to hear the word Flink now? All right. Now talking about the Spark features. In-memory computation. In-memory computation, which is missing in Tej. Distributed execution. Distributed execution, which is not found in HANA. Parallel processor. Parallel processing. And very high speed as compared with other technologies. Very high speed. It has got very high speed, right? Multi-language support. Supports advanced analytics. Supports advanced analytics. Transformations can be reused. Good for iterative algorithms. Good for iterative algorithms. Flexible parallel process. Okay. So these are the main Spark features, right? Now talking about this Spark data objects RDD, right? Resilient distributed data set. resilient distributed data sets. Spark data objects. See, Hadoop data objects. We talk in Hadoop data objects are what? Files. In Hadoop data is stored in the form. Spark data objects. RDD, resilient distributed. Yeah, RTD is again subdivided, right? RTD is again subdivided into partitions. RTD is again subdivided into partitions. These partitions are distributed. They are distributed. These partitions are again distributed across multiple RAMs of multiple worker nodes, slave nodes, and are processed by worker nodes and are processed parallelly. RTD programming style. RTD programming style is a data flow. RTD's programming style is data flow. What is data flow? Data flow is a sequence collection of pipes. What is a pipe? A pipe is a data operation. A pipe is any data operation. It is any data operation. What is a data operation such as loading data, Pipe is any data operation such as loading the data, transforming the data, loading the data, transforming the data, filtering the data, grouping the data, merging the data, loading data, transforming the data, filtering the data, grouping the data, merging the data, sorting the data.
Sir, here also like it will execute this whole process one by one only, right?
One sec, I'm coming to that. Yes. So here a pipe is any data operation such as loading data, transforming data, filtering, grouping, merging, sorting, right? Yes. In Spark, data flow is executed. Just now you asked, right? In Spark, data flow is executed sequentially. That is RTD by RTD, RTD by RTD, one after the another.
So like in Hadoop also, like you mentioned, like first map will execute and then reducer will get executed, right? So there also it is sequentially.
Yes. So here, one second, I'm coming to that. So here it is a sequence RTD by RTD, one after the other in DAG style with with in-memory computation, with in-memory computation, with in-memory computation feature and persistence feature. Two RTDs, yes, two RTDs can never execute in parallel. Why? Because the output is of one will be the input to the next. Two RTDs can never execute in parallel. Two RTDs can never execute in parallel. But here, where can you see the parallelism? Where can you see the parallelism? Okay, they're executed sequential RTD by RTD. Two RTDs can never but if a RTD is divided, but RTD is divided. If a RTD is divided into 40 partitions, RTD is divided into 4. If a RTD is divided into 40 partitions, P1, P2, P3, then all these 40 partitions, can execute in parallel. All these 40 partitions can execute in parallel, or it is divided into 70 partitions. Think that, okay, RTD is divided into 70 partitions. All these 70 partitions, they can execute in parallel, P1, P2, P3. So on P70. P1 stored in system 1, it is system 2, in system 3, in system 4, so on. P1, P2, P3, P4, P70, right? This P1 to P70, S1 to S70, right? Yes. So they can execute in parallel. Because the output of one RTD will be the input to the next RTD, so that's the reason they cannot execute parallelly. So, but the partitions, every RTD will be divided into partitions. Those partitions will be executed parallelly. RTD executions means what? RTD executions means the partitions. They'll be executed, and once the output will be collected by the next one, again those partitions will be executed parallelly, again collected by the next one. In this way, yes. On a RTD, just if you observe on a RTD, two operations can be performed. Two operations can be performed. Transformations and actions. Transformations and actions. Transformations. Second is what? Actions. And already two things, two operations, transformations and actions. Transformations mainly are of three types. Transformations mainly are of three types. Each element transformation, right? Secondly, filter transformation. Aggregated transformation. Three types of transformations: filter transformations and aggregated transformation. Each element transformation. Example, map function, flat map. Flat map, flat map. ODD.map. Map some transformation, whatever transformation you're mapping. ODD.map. You're mapping some transformation. That transformation is going to be mapped with each and every element. Example. Adding 5,000 means, for example, to the salaries of each employee as a bonus. Adding 5,000 to the salaries of each employee as bonus. 5,000 you are adding for all 10 lakhs employees are there. For all the 10 lakh employees, 5,000 as added to the salaries. So mapping, you're mapping a transformation, salary plus 5,000. Salary plus 5,000. This transformation you are so mapping with each and every element. Salary equal to salary plus 5,000. One more example. Transforming. Transforming each element. Each element means, for example, employee name in such a way that first character first character in uppercase, and all the other characters in lowercase. If there are 10 lakh employees, all the 10 lakh employees, employee name first character, right, in the uppercase, and all the other characters in the lowercase, and all other characters in lowercase. Filter transformation. For filtering the data based on condition. Example, filter function only. We have got filter function available. Example, filter function. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 152 153 154 155 156 157 158 159 160 RT.filter, city equal to Hyderabad. Okay. Filtering based on condition. Aggregated transformation. For groupings and aggregations. For groupings and aggregations. Here we have got a group by key, reduced by key. Group by key, reduced by key. Group by key and reduced by key. For performing these operations, we have got a group by key, reduced by key. Note. If you apply any transformation on a RTD, the resultant again is an RTD. The resultant is again a RTD. If you apply any transformation on RTD, the resultant is again a RTD. So this is regarding transformation, 3 types. Mainly each element filter and aggregated transformations we perform. Second one is action. Spark is lazy evaluated. Until you perform action, you cannot execute the data flow. Compulsory to perform. So action, what do you mean by action? When an action is performed, on a RTD, then only the entire data flow. Then only the entire data flow will be executed. Then only the entire data flow will be executed from its root RTD. Then only the entire data flow will be executed from its root RTD. The following are some of the actions. The following are some of the actions that can be performed. On a RTD. First one, like collect. Collect means it collects, means your data is divided into partitions. All the partitions are distributed across multiple systems. Multiple systems are processing them parallelly. So once you say collect, it collects all the partitions. It collects all the partitions data. It collects all the partition data of different slave machines into client machine. It collects all the partition data of different slave machines into client machine. Example, RTD.collect. RTD.collect. Count. We have got another action like count. Counts the number of elements. Counts the number of elements. In a RTD. Counts the number of elements in a RTD. RTD.count. Example RTD.count. Next is take. Third one is take. Retrieve the first n number. Retrieve the first number of elements in a RTD. Retrieves the first n number of elements in a RTD. RTD dot take of 10. RTD dot take of 10. Next, save as text file. Save as text file. So storing the results of a computed RTD. Storing the results of a computed into HDFS. Storing the results of a computed RTD into HDFS. RTD dot save as text file. Save as text file. The path you can provide. Path you can provide. Once again, I'm writing here the note. On a RTD, if we apply any transformation, any transformation, the resultant is a RTD. The resultant also is an RTD, means Spark object. The resultant is a Spark object. Yes. On a RTD, if we perform an action, on a RTD, if we perform an action, if we apply an action, the result is not a RTD. The result is not a RTD. It will be local object. It will be a local object. That is Python object. If you apply transformation, it is a Spark object. If you apply an action, it is a Python object. For example, in the last class I was saying, right? So using Spark context dot text file, Spark context text file. If you're loading a file path, then RTD1 is created. What is that? RTD1 is created. How RTD2 is created? From RTD2, from RTD1 dot map operation. Map is a transformation. Map is a transformation. With some transformation, you are mapping with some transformation. Here the result is an RTD2. RTD2 is equal to RTD1 dot map. Again, on RTD2, if you perform any transformation, filter transformation, again the result again is an RTD. A new RTD3 is created. RTD3 is created. Again on this RTD3, Hmm. Again, this RTD3 dot map something. RTD4. Hmm. RTD4 dot group by key. RTD dot group by key. That RTD5 is created. So in this way, transformation on an RTD gives the result is a new transfer group by key. Finally, if you want to execute this entire flow on RTD5 dot collector, RTD5 dot collector. RES is a local object or Python object. Here RES is Python object. Python object. Because when it's a Python object. Because here action means collector. It returns a Python object. Python object like Python list it provides. Where all these 5 RTDs are stored. Where all these 5 RTDs are stored, everyone. Where all these 5 RTDs are stored, yes. Where all these 5 RTDs are stored.
In memory.
If we perform action, then only one by one RTD will be loaded into RAM. If we perform action, then only one by one RTD will be loaded into RAM. Then only one by RTD. We perform action, then only one by one RTD will be loaded into RAM and will be processed. Whenever next RTD is ready, previous RTD will be removed from the RAM. Then the previous RTD will be removed from the RAM. This process continues. All the RTDs are executed and the action is completed. Okay. Transformations, right? Transformations transformations are executed at a Spark cluster side. Spark cluster side. The result in the client machine. Okay. Now just check with this, right, everyone. So understood how this different types of two operations we can perform in an OTD. Two operations we can perform on an OTD, right? There is transformations and actions. Transformation on an OTD, again, the result, if you perform a transformation OTD, again, it results in OTD only, Spark object. But when you perform actions, right, the result is a Python object, not Spark object, right? Yes. Check with this example, right? Yes. Now, the importance of persistence in Spark. The importance of persistence in Spark, right? What is the importance of persistence in Spark? For example, R1. Just check this R1, RTD1, Spark data object. From this, the output of this is given to input to R2. R2 output is given as input to R3. From R3, this output of R3 is used by multiple flows. R4, R5, R6, R7, R8, R9. Everything taken care by this framework only. You no need to do anything. Just you need to say which one to be persisted. So here, this is flow 1. This is this entire thing we call it as flow 1. This is flow 1. This entire thing we call it as flow 2. Flow 2. And this entire thing we call it as flow 3. What is flow 1? Three different flows. Here we have got three different flows. What is flow 1? R1, R2, R3, R4, R7. Flow 2 is what? R1, R2, R3, R5, R8. Flow 3. R1, R2, R3, R6, R9. R1, R2, R3, R4, R7. R1, R2, R3, R5, R8. This one. Executing flow 1. Executing flow 1, right? Yes. If you want to execute flow 1, what you need to do? R7 dot action collect, you say. R7 dot collect means this entire flow from first to last it executes. R7 dot action means first R1 loads and all these partitions will be loaded into RAM. They get executed parallelly. The output of it will be given as input to R2. Now R2 gets loaded. R2 loads computed. Then R1 will be removed and its partition will be removed from the RAM. And R2 output will be taken by R3 and R3 partitions will be loaded into RAM and gets computed. Once it is ready and computed, this R2 gets removed from the RAM. R3 and R4. When all four partitions loaded and computed, this part R3 and its partitions will be removed from the RAM. Similarly, R4 to R7. Yes, when R7 is loaded and computed, this is removed from the RAM. When R7 output is collected, R7 also removed from the RAM. No RTD in the RAM. No RTD in RAM. Now you can trigger the next flow. Next flow to flow 2 means R8. On R8 I need to perform action R8 dot collect. If you say R8 dot collect, then only this entire flow will be executed from its root. Mhm. So first R1, R2, R3, R5, R8. R1, R2, R3, R5, R8. When R2 is loaded, R1 gets removed from the RAM. When R3 is loaded, R3 is partitions gets loaded, R2 gets removed from the RAM. When R5 gets loaded, when R8 loaded, R5 and its partitions will be removed. Once finally the output is collected, then this R8 and its partitions also removed from the RAM. Now, how many RTDs in the RAM? No RTD in the RAM.
Sir, R1, R2, and R3 is common for all three flow, right? Then
Yes,
why it is trying to load and execute again?
I'm coming to that query. So here, oh yeah, you'll be seeing that for that only persistence. To avoid that only, we go for persistence. First, I'll show you the problem statement. Later, I'll show you how you can solve it. The problem is what you asked for. On and dot collector from R1, R2, from R2, R3, from R3, R6, from R6, R9. So this will be loaded first. The output will be collected by R2. When this is ready, this gets removed. When R3 is ready, this R2 gets removed from the RAM. And when R6 is ready, this gets removed from the RAM, right? Yes. When R9 is ready and R6 gets removed from the RAM. When the output is collected, this R9 also removed from the RAM. So no RTD in the RAM, in the RTD. But here, what is your observation here? When all the three flows are executed, no RTD remains in the RAM. But in all the above flows, flow is re-executing from the starting. In all the flow, what is the commonality you observe? The three things, right? Every time in each flow, it is re-executing. Every time it is re-executing. Every time it is re-executing. It is re-executing from the beginning. Even though the first three steps are common, still it is re-executing from the starting. So to avoid this, we need to identify the RTD whose output is commonly used by many flows. Yes, we need to identify the RTD whose output is commonly used by many flows and make it persist. Make it persist means it won't be removed from the RAM even though the next RTD is ready. And it provides the output to different flows and provides output to the different flows. Okay, so identify this R3, we are identifying this R3 and make it persist by saying R3 dot persist. We have got a persist method. To make it persist, we have got a persist method is available, right? Yes. Okay. So identify the RTD and make it persist. We have persisted it. Now in the above example, R3 output is used, so we have persisted it so that the flow no need to execute from the beginning. So now at the same thing, observe here. R1 is there, R2 is there, R3 is there. From R3, your R4, your R5, your R6, R7, R8, R9. This is your flow. And this your persist, R3 dot persist. Now observe flow one, execute the flow one now. Now you execute the flow one after persisting. Whenever you are saying R3 dot persist, after persist, you execute flow one. Flow one means R7 dot collect, R7 dot collect. Okay. Whenever you say R7 dot collect, first R1, R2, R3, R4, R7. Observe this, right? R1 ready, and the output is given to this R2. When R2 and its partitions loaded and computed, R1 gets removed from the RAM. Now, when R3 is ready, R2 gets removed from the RAM. Now, when R4 is there, right? R4 is ready and computed. R3 won't be removed from the RAM. What do you mean by persist? What do you mean by persist means making the RTD available in the RAM even though the next one is ready. R3 won't be removed. When R7 is ready, R4 gets removed. Once the total everything is output, total execution is finished, R7 also removed from the RAM. Now R3 in the RAM, right? R3 in the RAM now. Only R3 is available in the RAM. Why you are making R32 available in the RAM means its output can be given to many other flows, making it available in the RAM so that the same output can be reused by many other flows, reusing the already executed transformation. Now execute the flow 2. Flow 2 when you execute, right? R8 dot collect you will say. Whenever you say R8 dot collect, it will check from R8. R8 where it has to take the input from. R8 input is R5. R5 input is R3. So where it has to start? R3 is available. R3 is available in RAM. So no need to re-execute from the beginning. So the flow is, no need to execute from the beginning. The flow is from R3 to R5 to R8. No need to re-execute from the beginning. Once R3 executed, once R5 is loaded, R3 will be there in the RAM. When R8 loaded, R5, when the output is collected, this also remote. So R3 in the RAM. So R3 in the RAM. Now it is not re-executing from the beginning. It is reusing that already executed transformation. Now if we observe this flow 3, in the flow 3, R9 dot collector. R9 dot collect. So again, R9 input is what? R6. R6 input is what? R3. R3 in RAM. So directly you can take R3 output and compute the other flow. So the flow is from R3 to R6 to R9. When R6 is ready, R3 is still available in the RAM. Where R9 ready, it's also available. This gets removed. When total output is collected, this removed from the RAM. So R3 in the RAM here also, R3 in the RAM. Means whenever you persist in RTD, the RTD will be available in the RAM to give its output to the other flows. So R3 in the others. So once your executions are finished and you doesn't want R3 in the RAM, you want to remove R3 also from the RAM. Forcefully unpersist it by saying R3 dot unpersist. Forcefully unpersist by saying R3 dot unpersist. It gets unpersisted. It gets removed from the RAM immediately. Immediately it gets removed from the RAM. Persist won't happen immediately, but unpersist happens immediately. What is that? Unpersist happens immediately, but persist won't happen immediately. Why? When it has to be persisted, for example, in the first flow, when you will persist R3, first R1 execution finished. Whenever you say R3 dot persist, immediately it won't go and persist R3. First R1 loads, next R2 loads. When R3 is loaded, then it will be persisted. Until then, you won't persist. For example, if you have got a very big flow, R1 to R70, R50 you want to persist. Before that 49 RTD should be loaded. Then whenever R50 loaded, it will be persisted. Until then, it won't persist. But unpersist, immediately it happens. Immediately unpersist R50 means immediately it removes from the RAM. So this is what the importance of persistence means. You no need to, for example, if you take a very big flow, this is very small flow, you won't understand this importance of persistence. But if you have got a very big flow from R1 to R1 to R2, so on R50, R50 output is used by R70, used by R80, R90. So if you persist this, right, the first one you will execute this entire flow. But for the second task, right? But for the second flow onwards, no need to re-execute from the beginning from R50 to R80 because R50 is persisted available in the RAM. So that output you can take and compute. R90 also. That is the importance. Means in second flow and third flow, whenever you are executing, no need to re-execute from the beginning. 50 steps decreased. R50 output is ready is available in the RAM. Can collect it and just go with the other flow. Understood. That is what the advantage. So in-memory computation is one advantage of Spark. Very high speed, RAM level storage and RAM level processing and persistent free already executed transformation output can be reused. Lazy evaluated whenever you want, where you want, right? And perform action and you can execute that flow. See, whenever you want means whenever you say R4 data action means flow executes from R1 to R4 and R4 output will be collected. Whenever you say R7 dot collected, flow executes from R1 to R7 and R7 output will be collected. Whenever you say R5 dot collect means R1, this R5 up to this R5, the flow executes and this output will be collected. So this is what, okay, fine. So the main features, persistence feature and Spark has got a powerful fault tolerant model. In the next class, I'll discuss the fault tolerance model in Spark. Means it has got powerful fault tolerance when your Spark data is distributed across multiple systems. Then if any system goes down, then Spark has capability of regaining this lost partitions and compute it. Yes, understood everyone, right? So just you can go through this syllabus, core syllabus, right? In brief, in depth, we'll be discussing with all this PySpark introduction, PySpark RTD computations, persistence options, PySpark core computations, fault tolerant model, groupings and aggregations, various inbuilt actions and transformations one by one with many working examples, PySpark data frames, creating data frames, struct, column, select, collect with column, where, filter, drop, order by union, UDF, fill nulls, right? PySpark SQL functions, aggregate functions, window functions, data and timestamp, various inbuilt functions of PySpark one by one with many working examples. PySpark external sources with integration with Hive, integration with MySQL databases, narrow and wide transformation, handling nulls, deployment modes, local and cluster mode, PySpark applications, states and task driver and executor, right? PySpark streaming concepts, integration with Kafka and MLA, right? This is what I'll be discussing. You'll be getting each and every session video. You'll be getting this class soft copy of this class notes. One second, I'll just forward this notes now itself. One second, hold on. And you'll be getting the soft copy of these notes in the WhatsApp group. Next Saturday, the link will be changing. So those who have already enrolled, it's fine. But those who are supposed to, those who didn't enroll, try to enroll to get added to the WhatsApp group to get the videos and notes. But next week, the link will be changing. Yes. So you're supposed to get enrolled for getting the link to your mail, right? You can see in the chart a big message is given by this online team or the payment process. So if anyone missed the session yesterday's, right, you can check with that video, the course content, that contact details of this online team. Right, one second. Now you can see. Second.
Sir, who is giving the instruction to refer the data from the persistent state?
What is it we want to refer?
So suppose like we are doing the persistent state on the R3, right?
Hmm.
Then earlier also like we weren't doing any persistence and it was starting from the R1, okay? And now we have done the persistence, so it has stored the data in the in memory, okay? But who
Mm-hmm.
is giving the instruction, okay, you do not need to go like before R.
Whenever you trigger any flow, right, automatically one by one RTD will be loaded and removed from the RAM. One by one RTD will be loaded and removed from the RAM. But the persisted RTD won't be removed from the RAM until you forcefully remove it by unpersisting it.
Oh,
So this all just as a programmer, right? You need to say which one you need to say, what you want to perform, which transformation you want to perform, filter, map, grouping, or sorting or merging, and which RTD you need to persist. Remaining everything it will take care about the partitions, those things, right?
sure. Probably next weekend we are starting the programming, right?
Okay. What is it? So next week, just in the first Saturday, I'll be discussing about fault tolerance, and later we'll go with the practical part. Yes.
Oh,
So yes, next Saturday, just on fault tolerance and different ways of persisting is there. There's some discussion I'll be later. Immediately, we'll go with the practicals. Yes. Now, 1 second, you can check the notes what we discussed yesterday and today. Fine, you can see just I'm keeping in the Zoom chart. You can just download it. 1 second. My spot. So I'll be going with different ways of creating an OTD, different ways of creating an OTD, and after that different one by one action, one by inbuilt actions in build to transformation. Can see right PySpark introduction notes, whatever we have discussed yesterday and today. This clear notes starting with Apache Spark, why defining Apache Spark, why PySpark, Scala and Python differences, PySpark features, motivation towards the Spark, Tej and Spark, HANA and Spark, Spark mainly designed for MapReduce and Spark, Spark and Pig, Spark and Flick, PySpark main features, RTD, what is RTD and how it is, and two operations you can perform in an RTD, transformations actions, and what are some of the transformations, some of the actions I discussed, but still we have got many more. We'll be discussing all those practically, right? Yes. Fine. Any other queries, right? Next Saturday, same time at 6:30, but from next Saturday, we'll have 2 hours class, right? For Spark. We'll have 2 hours on Saturday, 2 hours on Sunday, right? Spark class will be for 2 hours, right? Yes. Okay. So if I'm done with the queries, if there are no other queries, I'm signing off for now. Meet you next Saturday, right? So try to get enrolled if you're not enrolled, right? For getting the link and the videos, right? Fine. A separate WhatsApp group will be created for this PySpark next Saturday.